In this video, we will solve the next problem related to Lami's theorem here. Okay, it is normally the applicable for the cylinders. Okay, first we will read the problem here, and here you can see here the picture. It's some cylinder is there. Okay, a smooth circular cylinder. It is a smooth circular cylinder. It is a solid or hollow. It's a cylinder is there of radius 1.5 meter. Okay, so data is given the radius. Sometime the data, the radius, the r equal to 1.5 meter is given of the cylinder. Okay, is lying in a triangular groove. Is lying in a triangular groove. A cylinder is there. Cylinder of its radius is 1.5 meter, and it is resting on a triangular groove. Triangular groove. It is triangular groove. One side of which makes 15 degree. The one side of which makes 15 degree angle, and the other side makes 40 degree angle with the horizontal. It means, see here, this is a cylinder. This is a cylinder of radius 1.5 meter. It is rests on a triangular groove. Some groove is there. This is triangular groove. The one side, what he said here, lying on a triangular groove, one side of which makes 15 degree. Whatever it rests on a groove, it makes 15 degree to the horizontal, and the other side it makes 40 degree to the horizontal here. It rests where the contact is there, that contact makes at an angle of 15 degree with the horizontal and 45 degree with the horizontal. 2 points is given here, this point and this point here. Okay, find the reactions. Where we will get the reactions here? Obviously where it contact, where it sits, the cylinder sits, there is the reactions. Here one reaction you will get, we'll consider that is Ra, and here one reaction will get Rb. Okay, he is asking find the reactions at the surface, at the surfaces of contact. Because its contact surface is here, you will get the reaction Ra and Rb is here. Okay, if there is no friction, it means you have to consider the friction is negligible. It means don't consider. Okay, if there is no friction, and the cylinder weighs 1000 Newton, its weight is 1000 Newton. That is the weight of the cylinder is 1000 Newton. This is how the problem. Just overview once again I'll give here. A cylinder is there. It sits on a groove, on a triangular groove. The one side of contact makes at an angle of 15 degree with horizontal. The other side it makes at an angle of 40 degree with the horizontal. Obviously when it sits, there is a reactions. There is a two reactions it will be generated. One is Ra, one is Rb here. Okay, and the weight of the cylinder is 1000 Newton. Whatever it will be in downward direction, right? Because obviously it will be due to gravity. It will goes down in the downward direction. Okay, you have to find out the reactions at that point, at the surface of contact here. Now we have 2 points we have to consider here. We have to let just note down here. Let Ra equal to reaction at A, right? Reaction at point A. Here. You just give it this one as A and this one as the B point. Okay, at A, and Rb equal to reaction at point B here. Okay, so one condition is, in order to put this is in the equilibrium problems. Okay, in order to put the cylinder is in equilibrium with the groove, whatever the line of contact, the line passing through, and the Ra and Rb and the weight of the cylinder must pass through the center of the cylinder. That is one condition. The first condition is to keep the system in equilibrium. The reaction, the line of reaction Ra and the line of reaction Rb and the line of the load, the line of the cylinder, the weight of the cylinder must pass through the center of the cylinder. That is one condition. And second one is, he's saying that there is no friction. Between the surface and the cylinder. At that condition, always the reactions are normal to the surface. It means this is 90 degree and this is also 90 degree. Here this is 90 degree and this is also 90 degree. Always the reaction is acting the 90 degree to the surfaces, these two are the conditions here you have to apply here. Okay, just we'll write here, in order to keep the system equilibrium, in order, first point here, in order to keep system in equilibrium, in order to keep the system in equilibrium, three forces. What are the three forces? What are the three forces? That is RA, RB and the weight of the cylinder, right? RA, RB and weight of the cylinder must pass through center of the cylinder. This is one condition to keep it balanced, system to be balanced. The second one, since there is no friction, RA and RB are normal to the surfaces. Normal means perpendicular, normal to their surfaces. These two are the conditions. Now, if you pass through the RB in the center and RA in the center, and load is 1000 Newton, it will be at a center of the cylinder here, just can I write it this one as this is passing through here, just I'll write this is RB, and this it is passing through the center of the cylinder, this is RA. Now if this is 40 degree, with the horizontal, because this and these two are the 90 degree. Similarly here, if this is 40 degree, here also you will get the 40 degree here. This angle you will get 40 degree. This angle you will get 40 degree. And if this is 15, this surface is 15 with the horizontal, these two are the 90 degree. Related to this, the vertical angle is 15 degree you will get here. Okay. Now if this is 15, just extend this one. This is 40. Can I write it? This one is 40 degree. As you know, like this angles. If this is 40 degree, this is also 40 degree, right? So can I write this one as 40 degree? And if this is 15, I can write this one as 15 degree. Okay. See here, if this 40 with the horizontal, with the vertical it is 40. If this is the 15 degree with horizontal, with vertical it is 15 degree. Now extend the load here. Because I want to apply the Lamis theorem, so that's why I am applying the here. If this is 40, this is also 40. If this is 15 and this is also 15 here. Okay. Now apply the Lamis theorem at point O. Apply. Just I'll draw the free body diagram. You will come to know here. This is point O. One is RB, right? This is RB. RB is passing through at point O, and the RA is passing through. This is O point, right? And RA is passing through here. This is RA, and weight of the cylinder 1000 Newton, downward direction. Weight of the cylinder 1000 downward direction. Okay. Now here also you have to apply the angles here. Just I am applying here. This is how much here? This angle is 40 degree. This is 40 degree and this is 15 degree, right? This is 15 degree. Now if this is 40 degree, how about this one here? 180 minus 40. 180 minus 40 is how much? 140, right? This is horizontally, the vertically line is 180, minus 40 is 140. This angle is 140. 140. If this is 15, how about this angle here? 180 minus 15. The vertical line is 150 minus 15 is, the 180 minus 15 is 165. 165 degree. Okay. Now finally you can, I'll draw one more figure here. Just one is vertical downward. This is one, and this is one more here. And this is RB. And this is RA. This is O point, and this is 1000 Newton. 1000 Newton. So how about the angle here? 140. Between RB and the load is, it is 140. Between RA and RB is 40 plus 15, how much? 55 degree. This is 55 degree. Between RA and 1000 is, it is 165 degree. This is 165 degree. Okay. Now can I apply the Lamis theorem at the point O of the cylinder? Apply Lamis theorem. At point O. So RA, first I'll write RA divided by sine of opposite of these two sides, the sine of angle between the other two sides here. Angle between other two sides is 140 degree. 140 degree equal to RB divided by sine of the angle between other two forces. Other two forces is 165. That is 165 equal to 1000 divided by the sine of angle between the other two forces. RA and RB is the 55 degree. 55 degree. Okay. Now use this and this final one, you will get the unknown value RA. Okay. And similarly use these two equations, you will get the RB value. That is RA equal to, just I'll write here, the RA divided by sine of 140 equal to 1000 divided by sine of 55. Right? Sine of 55. Therefore RA equal to 1000 into sine of 140 divided by sine of 155. Substitute and calculate. Okay, simplify. Therefore the RA will get here 784.7 Newton. After simplification, 784.7 Newton. This is the RA. The reaction is, the how much here I am getting here, RA reaction here. This is my reaction. This will be equal to 784.7 Newton I am getting here. Similarly, substitute these two equations in this equation, right? So RB, that is RB divided by sine of 165 equal to 1000 divided by sine of 55. Substitute and simplify. The finally RB, after simplifying, the RB value will get 315.9 Newton. 315.9 Newton. This is the RB value. Okay, where is the RB here? This is RB. RB equal to 315.9 Newton. This is how you can apply the Lamis theorem in the cylindrical type of problems here. You just check it, the conditions and what is the problem data is given. Apply the conditions properly, boundary conditions and all, and apply the Lamis theorem to solve the unknown values here. Okay.